page 19. Reminder, okay? There are 3 words for now, and then we're going to add one more that are really important. Accuracy. Accuracy stands for how close you are to the target, okay? That's what accuracy means. Very shortly defined. Precision is the smallest increment of the measuring device. And how you find that out, that is depending on the situation, right? If it's a picture, whatnot, you need to figure it out. And then uncertainty is always half of the precision, right? And uncertainty is also known as the margin of error, like how much you could possibly be off by, okay? So those are the terminologies you need to know. Accuracy can be affected by, there are a couple of things that affect it. The 2 that I kind of pair up is improper use or damaged device. Okay, that's going to affect how well you can measure something. The other 2 that I kind of pair up would be the unit that you've used. Is it standard or is it like a handspan or something? Like standard is centimeters, kilometers, right? Milliliters, things like that. And is the scale appropriate? I will say this about the unit and the scale, guys. Only use that one if the question makes reference to it. You know what I mean? Like somebody used a meter stick to determine the distance between 2 cities, right? It's probably not a good scale to use in that case, right? Because you're presented with what has been used, right? I would rather use the improper use or damaged device to a certain degree. I don't think I did talk about, right, leveling off. Like if you're using flour, if you're going to use a cup to measure flour, make sure you level it off. Make sure you don't use milk, right, to measure milk and then flour, right? What's going to happen? A lot of the flour is going to get stuck on the edges, right? So that's improper use, in my opinion. Okay, so sometimes you just have to use your imagination to make it work. Anyways, let's dive into this page right here. So I want you to, every single scenario, state the measurement plus or minus the uncertainty, okay? And then we'll go minimum and maximum. That's part B, but this is the most important part. So over here, let's focus on the precision and the uncertainty first. If you look at this, the precision is 1/10 of a centimeter or 0.1 of a centimeter. If you want to say a millimeter, that is also correct, because 0.1 of a centimeter is a millimeter, right? The smallest markings on a meter stick or on a ruler are usually millimeters, so that is also okay to say. So all 3 of these are fine. Uncertainty, therefore, would be 1/20 or 0.05. If you go by that, centimeters, these are all centimeters, or 0.5 of a millimeter. So I know it's a little confusing. It's like, why so many? You pick one. You pick one. Like if you want to use fractions, if you want to use centimeters or millimeters, you pick. That's all I'm going to say there. Don't do all 3. It's not necessary. Now, the measurement. What is the measurement? That's a little tricky. So you kind of have to draw a line to the ruler and determine which one is this one closest to. And I would say it's closer to 38. I think it's a little unfair. It's hard to see. But this one is a little closer to 38 millimeters. So we go 38 millimeters. Maybe let's put it on our, this is the 38 millimeter mark here. That's where I got it from. So 38 millimeters plus or minus. You may use centimeters or you may use millimeters to answer this one. I'm going to stick to millimeters or 38 millimeter. Put units everywhere to be safe. 0.05 centimeter. That is also okay. Okay. And maybe there's someone in the room that said this is 3.8 centimeters. You are also correct. So when it comes to metric, it's base 10. So it's just basically the decimal shifts. That's what's happening. Okay. So this or that. So this is basically answering question A. right? It's one of these two is where you measure. You have the, and in this case, they didn't give you a measurement, right? You had to go off of the picture to come up with the measurement. Okay, so I basically grab the 38 from here, and I grab the uncertainty. I did a little bit of work to come up with it, right? And now the min and the max, okay? So let's do B here. To get the maximum possible length of this piece that has been measured, I will go 38 plus 0.5. So it could be 38.5 millimeters. And the minimum, the shortest that piece can possibly be, would be 38 minus 0.5. So that's 37.5 millimeters. I think the most important thing is to know how do I find what I've been asked to find? How do I do that? Okay? Because I could just ask you, the province could just ask you for the max, then you stop, right? It could just ask you for the min. They are also obviously going to test if you are actually reading. So they might say, hey, what's the longest possible, right? What's the maximum length of this piece? You should know that is max, right? So it's not necessarily going to be exactly the way I demonstrated it here. Let's do an imperial ruler here, inches. How would you measure this? Well, first figure out the precision and uncertainty. The precision, you check 1, 2, 3, 4, 5, 6, 7, 8. So it gets me 8, gets me to the middle. So I know it's going to be another 8 going here. So 16 gaps, right? So you know that this one is down to the nearest 16th of an inch. The uncertainty is therefore 1/32 of an inch. And we can turn that into decimals, right? So this would be 0.0625. And the uncertainty would be half of that, right? 0.03125. And these are all in inches, so you got to make sure you write that in inches. So now measure it. How long is this piece? It's the line is right here. Is it closer to 1.5 inches, or you can say 1 8/16? Like if you're not sure, just count how many marks. This would be 8/16 right here, okay, which is half. So the measurement is 1 8/16 of an inch. If I did this in woods, my teacher probably, or don't tell your woods teacher that I did this, okay? It's like, that's half. Plus or minus 1/32 of an inch. So you can state it that way. If you don't like writing it this way, you may use 1.5 inches plus or minus 1/32 of an inch. Okay, you may do it this way, right? So you can say or. That's how you did it. Better yet, let's say you hate fractions. What's 1.5 as a decimal, right? You would just go 1.5 of an inch, and then plus or minus, figure out what 1/32 is. We know that it's this. So you just, without rounding, write everything as a decimal. 0.03125. Okay? And then from there you get your max and your min. So I'm just going to go max here. Min goes here. If you add, you get 1.53125 inches. And if you subtract, it's 1.46875 of an inch. So these are the possible greatest and or longest and shortest piece there. So be comfortable with that. This one, what's the precision? From marking to marking, that's what it's at, right? Marking to marking, you can tell it's 10, right? 10 centimeters. Uncertainty is therefore plus or minus 5 centimeters. We got that out of the way. And you mark here, which one is this closest to? Which marking? It's closer to 20. Okay? So you need to say this one is 20 centimeters plus or minus whatever my uncertainty is. This is more than likely what you're going to see on an exam. They kind of try to stay away from the very crazy decimals, fractions, but I need to prepare you because you never know. So from here, what do we call this part right here? This part right here is what? Measurement plus or minus the uncertainty. Okay, so if I asked you for that, then you stop right there. Don't continue. But if I ask you for the maximum, now you need to add these up. That'd be 25. And the minimum would be 20 minus 5. So you're saying this piece could be 25 to 15, which is a little ridiculous. If you look at that ruler, you're like, obviously it's 18, right? And you just have to kind of stay away from that reasoning. Just resist the temptation, and you'll be fine. Okay? Resist the temptation. Are we good here? You're awake? You're with me? All right. I'm going to pause here, and we'll see how